Okay, this is exercise 9E. We're looking at the logarithmic function base e and its graph. Now, a few lessons ago, we looked at y equals log to the base 2 of x. Now, this graph is very similar to that. And so it'll basically take on that shape. So this is the graph down here of y equals log to the base e of x. So this is equals log to the base e of x. This dotted line here is the line y equals x, and this other line here that you can see is what we were looking at last lesson, which is the graph of y equals e to the x. Now, the reason that we have the line y equals x here is that the graph y equals e to the power of x and y equals log to the base e of x, they are, as you can see, they are reflections of each other in the line y equals x. And this makes them inverse functions of each other. And we'll look into that a little bit further on the next page. Okay, so first we're just going to look at a table of values for both these functions and just sketching them. I'll just let you complete those here. Okay, now you've sketched that before. You can actually plot those points. I'd like you to also plot some of those points on the graph, like 0, 1, 1e. Okay, that makes sense. It's about 2.7. You don't have to do that. You can't fit the 0.2 e squared. And we've got -1 and 1 on e. Okay, we can see that the domain is all real x, that y is greater than 0 is the range, that there are no zeros. So the graph does not cut the x-axis, and the curve is always above the x-axis. We can see that the x-axis here is a horizontal asymptote on the left, and as x approaches -infinity, y approaches 0 from above. And over here on the right-hand side, the curve rises steeply. And so as x approaches positive infinity, y approaches positive infinity, and the curve is always concave up. So you can just check that you've got these correct answers here. And now looking at the graph of y equals log to the base e of x, we substitute these different values of x. Let's just start over here with log to the base e of 1. Now we know that log to the base a of 1 is 0. Log to any base of 1 is 0. You can just check this doing using ln, the ln function on your calculator. ln1 is 0. Log to the base e of e, we know that that is 1, but you can also do ln of e on your calculator. And log to the base e of e squared, so if I just do a little bit of, you can do a bit of working out over here. So log to the base e of e squared, we know we've looked at these before. The 2 comes to the front, 2 log to the base e of e, and we know that log to the base e of e is 1, so it's 2 times 1 is 2. This one here, log to the base e of 1 on e is the same as log to the base e of e to the power of -1. Because 1 on e is e to the -1. The -1 comes to the front, so it's negative log to the base e of e, which is -1. And if you do the same here, you'll get log to the base e of 1 on e squared, or e to the -2. -2 comes to the front, and you end up with -2 there. Okay, now we can, I just want you to go down and plot those values. Okay, look, you won't be able to do 1 on e squared and 1 on e. But you can do the points 0, 1, 0, and we've got the point E. So we've got the point, let's look at these, E1 and E squared 2. Now E is approximately 2.718, so this point here must be E1. We can see we've got 0, oh sorry, we've got 1, 0 here as well, okay? And here, this would be 1 on e -1, okay? All right, so that's the curve y equals log to the base e of x. You can see that the domain is only x values greater than 0. Now, look, we were looking at some logs last week or the week before, and you cannot take the log of a negative number, which is why you can only, this log to the base e, the ln curve, or the log to the base e of x curve, has domain x greater than 0. Now the range seems to be all y values, so y, all real y. And we can see that here, this is the y-axis, that the y-axis is an asymptote. So the y-axis is a vertical asymptote, okay? And as x approaches 0 from above, so from the positive numbers as x approaches 0, so here, for example, x will be 1, x is 0.2, x is 0.1, x is 0.01, etc., etc. So as x approaches 0 from the positive side, we can see that y approaches negative infinity. So you can start to fill this out, okay? All right, so we've got the domain, values of x must be positive for a logarithmic function, that the range is all real y. We've got the y-axis is a vertical asymptote. As x approaches positive infinity, as x approaches 0 from above, y approaches negative infinity. We can also see here as x approaches infinity, or positive infinity, y also approaches positive infinity. All right, but quite slowly, all right? And the curve is always concave down. Okay, so if you compare those two, okay, you can see that you've got some opposites happening here, okay? X-axis is horizontal asymptote, y-axis is vertical asymptote. Domain here for e to the x is all real x, but the range is all real y. The range over here is y is greater than 0. The domain is x is greater than 0. If you look here at the x and the y values, they are actually flipped. So here, for example, e to the negative 2, that's 1 on e squared. I'll write it as 1 on e squared. So here we've got negative 2, 1 on e squared for y equals e to the x, but we've got 1 on e squared negative 2. Here we've got negative 1, 1 on e. Here we've got 1 on e, negative 1. 0, 1, 1, 0. 1e, e1, 2e squared 2. Now where you have this substitution basically, or swapping of the x and the y values, the functions are inverse functions of each other. So as we can see down here, the two graphs are reflections of each other in the diagonal line y equals x. This is because they are inverse functions of each other, so their table of values are the same, except that the y and x values, or the x and y values, have been swapped. We've also spoken about this before, but I'll just mention it again. Okay, so when we look at logarithms of base e, they're written as log to the base e of x, and you can also write it as ln of x, and on your calculator you will see the button ln. So whenever you want to take log to the base e, you use the ln button on your calculator, and that ln button is actually the inverse function of e to the power of x, which is why you see the ln button has, on most calculators, e to the power of x is above it. Now log, if you see the log function on your calculator, it is log to the base 10 of x, and its inverse function is 10 to the power of x, which is also why, for example, you can see on the calculators, actually you can't see very well on this one, but this log has 10 to the power of x on top, and this ln has e to the power of x on top of it. Okay, now you can use your calculator here to find these correct to 4 significant figures. So just looking at A part 1, log to the base e of 10, that will just be ln of 10 on your calculator. And to 4 significant figures, you should get, so I'm just going to go log to the base e of 10 is 2.3025, but to 4 significant figures, it would be 3. Okay, number 2. Just do these as is on your calculator. So you want ln of 1/10, and we get negative. So log to the base e of 1/10 is negative 2.3025, so 2.303 to 4 significant figures. And part 3, log to the base e of 100, so that would be ln of 100 on your calc. We're getting 4.605 to 4 significant figures. Now it's asking Part B is asking how are the answers to parts 2 and 3 related to the answer in part 1. So let's just look at B part 2, log to the base e of 1/10. Well, we know that that is log to the base e of 10 to the power of -1, because 1 over is a negative power. We know with our log laws that this -1 can go to the front, so it's -1 times log to the base e of 10. Now we know that log to the base e of 10 is 2.303, so it's basically the negative. So it's just the negative of log to the base e of 10. So that's how part 2 answer is related. And part 3 answer, log to the base e of 100, we know is log to the base e of 10 to the power of 2. And using the log laws where that power of 2 comes to the front, that's 2 times log to the base e of 10. So it's, well, I'll just put the time symbol in. So it'll be 2 times the answer to part 1. So this is the negative of part 1 answer. And this is 2 times your part 2 answer. Okay, because log to the base e of 10 is 2.303 or 2.3025. So when you multiply that by 2, you get 4.605. Okay. All right, now just for this next part here. Okay, now you've seen these, we've seen this before, that the logarithmic and exponential functions are inverse functions. So what that means is that when the logarithmic and exponential functions base e are applied one after another or successively to a number, the result is the original number. So we know from before this x would come to the front, for example, this power, so that's x times log to the base e of e, which is x times 1, which is x. So when you see log to the base e of e to the power of x, you get x. And we also saw this when we were looking at a log to the base a of x as well. So e log to the base e of x is also x, okay? So just using that then, log to the base e of e to the power of 10, it's saying just do these on your calculator. So you would press ln e to the power of 10 on your calculator. So you go ln and then you go e. So ln e to the power of 10. So you do this on your calc, if you can see that, actually like that. Ln e to the power of 10, and that equals 10, as you can see. All right, and e ln 10, you can do that on your calculator as well. So you've got e and then ln 10. So that's e log to the base e of 10. You can see that that's 10 as well. Okay, so you can do that. So ln 10 on your calc is 10, and e ln 10 we know is also 10. Okay, now question 4 here says to solve each equation of x by first rewriting it as an index statement. Now we've got here that x equals log to the base e of 1 on e squared, which is log, there's a few ways we can do this. So if we want to write it as an index statement, we know that e is the base. We would get that e to the power of x is 1 on e squared. So e to the power of x is 1 on e squared. So I'm just going to need a bit more room here. So just writing them both in the same format. So that would be e to the power of x. 1 on e squared is e to the -2. Now equating those two, bases are the same, so therefore x is -2. And also writing this as an index statement, we know that e is the base, so we have e to the power of x is the square root of e. We know that square root of e is e to the power of a half, therefore we can say that x is a half. All right, now we could have done those another way if we wanted. So for example, f, an alternative method, I could write that x equals log to the base e of root e. So this is just another way I could do it. Okay, so I could say, well, that x equals log to the base e of e to the half, and I know that that power of a half comes to the front, so it's a half times log to the base e of e. So therefore x is a half times 1, which is a half. So you could solve this, you know, two ways. And we could have done this one as well by writing log to the base e of e to the negative 2. And the negative 2 comes to the front, and then you'll get x is negative 2. Now, with this one here, it's saying, so this one we solved by first writing it as an index statement, which means writing it here as e is the base to the power of x is 1 on e squared. Now this one is just saying simplify each expression using the log laws, which is what I actually did over here. So that's using the log laws over here. So they're asking you to do that here in part 5. So we know that log to the base e of e to the power of negative 1, that equals negative log to the base e of e, which is negative 1. All right, or it's negative 1, you could say, times log to the base e of e. So I should probably write that negative, sorry, a bit messy. Negative 1 times log to the base e of e, which is negative 1 times 1, which is negative 1. All right, and this one here, that is the same as log to the base e of e to the power of negative 1. In other words, they're the same. Okay, which is negative 1 times log to the base e of e, which is negative 1 times 1, which is negative 1. And you could just check this, for example, by doing ln of 1 on e on your calculator. So ln of 1 divided by e to the power of 1 on your calculator will give you that answer, negative 1 as well. Okay, now you should be okay with these, using the log laws to simplify the following. Now just use one law at a time. So this is e times, now the 3 would come to the front, so 3 log to the base e of e, or I could have put the 3 out the front, it doesn't matter, minus e times, now log to the base e of e is 1, so I've got 3e times log to the base e of e is 1, so I've got 3e times 1 minus e, so it's 3e minus e, which is 2e. Okay, now actually yeah, I probably would do it that way. There could be other ways that you could do it as well. I'm just going to use an alternative method here. Let's say we've got e, I decided to factorize it. I could say that's e times log to the base e of e cubed minus log to the base e of e. Well, we could also use the index law where you're subtracting here is the same as doing division, which is log to the base e of e cubed on e. Okay, now that is e times log to the base e of e squared, which is, now the 2 can come to the front, e times 2 log to the base e of e, which is e times 2 times 1, which is 2e. So I've just shown you another way of using log laws there. So you can use the power law, all right, and just use the fact that log to the base e of e is 1, I suppose, or you could use this as well. So this one, if we're just going to use the log law, so we'll just do this two ways. So the log law would be when you've got the log with the same base and you're adding, it's the same as multiplying, so e times 1 on e. So that's the same as log to the base e of e times 1 on e is e on e, which is 1. Now we know that log to the base e of 1 is just 0. So we're getting 0 for that. Now the other way we could have done it is log to the base e of e plus log to the base e of 1 on e is the same as 1. Well, that's 1 plus log to the base e of 1 on e is log to the base e of e to the negative 1. So that's 1 plus, bring the negative 1 to the front, negative 1 times log to the base e of e. So it's 1 plus negative 1 times 1, which is 1 plus negative 1, which is also 0. So that just shows you two ways of doing that, okay? Now for question 9. Express as a single logarithm. Now you're going to have to use the log laws to do this. So we've got log to the base e of 100 minus log to the base e of 25. Now with that subtraction, remember that is division. So we've got log to the base e of 100 over 25, which is log to the base e of 4. Now that is not fully simplified because 4 is 2 squared. You must write it as 2 to the power of 2, and then I can bring the 2 to the front, so that is 2 log to the base e of 2, or I could just write that as 2 ln 2. So that is now, this here is expressed as a single logarithm. Now let's look at d, log to the base e of 54 minus log to the base e of 10 plus log to the base e of 5. Okay, we've got log to the base e of 54 minus log to the base e of 10. We know that is log to the base e of 54 over 10. And here we've got plus log to the base e of 5. Now I'm just going to simplify the 54 over 10 because that they can both be divided by 2 and you get 27 over 5 plus log to the base e of 5. Now when you're adding two logs with the same base, the rule is that you can use multiplication here. So it's 27 over 5 times 5. Now we can see that the 5's cancel and we get log to the base e of 27. Okay. Now, you could have also said, like, if you do this, you'll get 5.4 here, and you could have done 5.4 times 5, and 5.4 times 5 on your calc is also 27. Now, we know that log to the base e of 27 is log to the base e of 3 cubed, because 27 is 3 to the power of 3. So basically, if you can write this number as a power, you need to, and that way the 3 comes to the front, and we've got 3 log to the base e of 3, or 3 ln 3. So that is the most simplified version of that logarithm. Okay, now for some examples from question 11. It says to use the log laws and the change of base formula to prove this. Okay, so let's start with our left-hand side. Left-hand side is log to the base 1 on e of x. Now, the change of base, remember, what we'll do, we'll take them both to the base e. So that's log to the base e of x over log to the base e of 1 on e. Now, so we've applied change of base there. So that's log to the base e of x over log to the base e of e to the power of negative 1. So 1 on e is e to the power of negative 1. So that's log to the base e of x over the negative 1 comes to the front, negative 1 times log to the base e of e. Now we know that log to the base e of e is 1. So it's just log to the base e of x over negative 1 times 1, which is just negative log to the base e of x, which equals, you know, as required, or equals the right-hand side over here. And looking at the next example, C, starting with our left-hand side, is log to the base 1 on e of x to the power of negative 1. Look at what you're heading for, which is a log to the base e. So we'll take log to the base e, write it as a log to the base e. So actually, before we do that, actually, no, we'll just do that. Or actually, no, we won't. We'll just take the negative 1 to the front. So that's negative 1 times log to the base 1 on e of x. And just keeping that negative there and then doing the change of base. So it's negative log to the base e of x over log to the base e of 1 on e. So what I've done is I've brought that negative 1 to the front first. Then I've applied my change of base. Now, just rewriting this denominator, we've got negative log to the base e of e over log to the base e of e to the power of negative 1, and then the negative comes to the front. So I've got negative log to the base e of x over negative log to the base e of e. Now we know that log to the base e of e is 1, so it's negative log to the base e of x over negative 1, which is just log to the base e of x, which is equal to the right-hand side. Okay. Transformations of the graph y equals log to the base e of x. You did these for log to the base 2 of x earlier, like last week or the week before. So now I'm just filling in your table of values. This would be 1 on e squared, or e to the negative 2, which is negative 2, log to the base e of e. This would be e to the negative 1. Negative 1 comes to the front, so that's negative 1. Log to the base e of 1 is 0. Log to the base e of e is 1. And log to the base e of e squared is 2. Okay, now you can, I want you to, we've already sketched this before, so if you can fill this in, plot some points on your curve and then use these table of values with these values of x. Do your y values as well, all right? And you can see down here that this is log to the base e of x, so this is the point 0, 1. So this top curve, his y is log to the base e of x, okay? We've got the point 1, 0. We've got the point e, which is 2.718 about there. So this is e1, and this would be here, e squared 2. Okay, here you would have 1 on e, negative 1. Okay, now you can see your domain. You can put that this is your y-axis, mark in your x-axis. You can see the domain is x is greater than 0. Notice that for values of x between 0 and 1, you get a negative. The log of any number between 0 and 1 is a negative, okay? You cannot take the log of a negative number. All right, so the domain is x is greater than 0. The range is y, or real y. You can see that your y-axis is a vertical asymptote, and you filled this in before, so you can just do that again now. That's what we just spoke about. You did this before. Now, log to the base e of x minus 1, we would think that this would be a shift. When the shift is in brackets with the x, it's a shift sideways, and it would be 1 unit to the right. So if you choose the values of x of 1 and 1 and 1 on e squared, take 1 away from that, it'll give you the same value as 1 on e squared, which is, so this would become log to the base e of 1 on e squared, which is log to the base e of e to the negative 2, which is negative 2, 1 and 1 on e. So just think of it as 1 and a third, roughly, minus 1 would be a third, or in this case, 1 on e. That's e to the negative 1, bring the negative to the front. 2 minus 1 is 1, so this is the same as log to the base e of 1. When x is e plus 1, you get e plus 1 minus 1 is e. Log to the base e of e is 1. And e squared plus 1 minus 1 is just e squared, so you get log to the base e of e squared, which is 2. Okay, be careful here. This is the graph of log to the base e of x shifted 1 unit right, so the asymptote will change. Okay, so your domain, if you look down here, you might want to draw them in a different color, but this here is the point, say, 2, 0. We've got the point, this would be 1 and 1 on e, negative 1, and this here would be the point 1 and 1 on e, 1. Okay, so the whole graph has been shifted 1 unit to the right. You can see each point has been shifted 1 unit to the right. Okay, so, but just be careful here because you've got a new asymptote here, and you might want to mark it in something. This is the line x equals 1, and x equals 1 is an asymptote for your curve, for your new curve. Okay, so domain, be careful, is going to be x. This time x is greater than 1. Your range, again, is still all real y, and it's not the x-axis, sorry, it's the line. X equals 1 is a vertical asymptote as x approaches 1 from above. Y approaches negative infinity. And as x approaches positive infinity, y approaches positive infinity. So just be careful with those, okay? And you can also sketch y equals log to the base e of x plus 2. Now this is y equals log to the base e of x shifted 2 units, not to the right, but to the left. Okay, so if you can fill in your table of values and sketch it, and then come back and check your answer. If you put here for x1 on e minus 2, the minus 2 plus 2 cancels. It's log to the base e of 1 on e, which is e to the negative 1, bringing the negative to the front. Here, log to the base e of negative 1 plus 2 is positive 1. That's log to the base e of 1 is 0. If you've got e minus 2 plus 2, that'll just give you log to the base e of e, which is 1. and e squared minus 2, the minus 2 plus 2 cancels. Log to the base e of e squared is just 2. And now plotting that, we do know that it is 2 units shifted to the left. So I'm just going to plot those points 2 units to the left. So from here, that's y equals e to the x. You go 2 units to the left, and let's just check. We do have the point -1, 0. Okay, obviously it's going to be a bit hard to sketch these. E minus 2, that's about 2.718 minus 2, which is about 0.718. So you want 0.718, about, that's 0.5, about here, 1, all right? So it's actually 2 units across from there. So I'll just show you a bit better. So from here, 2 units across, about there. All right. Okay, and 1 on E minus 2, I think that's about, well, it's 2 units across from here. Okay, so 1, it's about there. Oh, a bit more, just about there. So the curve looks like this. Okay, and just be careful because your line, your vertical asymptote is going to be x equals -2. So asymptote is x equals -2, and you can see that your domain is x is greater than -2 as well. Okay. All right, and just doing one more point, 2 units across from here would be about 1, about there. Okay, and you can extend that along. Plot the points, you can just plot a couple of points there. Okay, so this is y equals log to the base e of x plus 2. Okay, and on the next page, if you could just complete the table of values for log to the base e of x. We already had these from before, and also the table of values for log to the base e of x minus 2. Now this is just log to the base e of x shifted 2 units down. Okay, so just doing some of the more familiar points here first. Log to the base e of 1 is 0, 0 minus 2 is -2. Log to the base e of e is 1, and 1 minus 2 is -1. Log to the base e of e squared is 2. 2 minus 2 is 0. Here, log to the base e of 1 on e is log to the base e of e to the -1. The negative comes to the front. You've got -1 minus 2, which is -3. And this other one, 1 on e squared, log to the base e of 1 on e squared is log to the base e of e to the -2. The -2 comes to the front. -2 minus 2 is -4. And you can plot those points down below. Okay, so obviously this top curve here that you can see is y equals log to the base e of x. You can just put in a few of the points that you've got. 1, 0. This would be e1. All right. This would be e squared 1. All right, so that's for y equals log to the base e of x. And your other curve underneath, perhaps in a different color, you've got there, you've got 1, -2. You've got e -1. Notice everything's been shifted down 2 units. And here you would have e squared 0. Okay, and this other curve is y equals log to the base e of x minus 2. And if you could also please complete the table of values for y equals log to the base e of x plus 1 and sketch that as well. I'm just starting with some of these easy ones. E squared there would be 2. Log to the base e of e is 2 times 1, which is 2 plus 1 is 3. Log to the base e of e is 1. 1 plus 1 is 2. Log to the base e of 1 is 0. 0 plus 1 is 1. And log to the base e of 1 on e is log to the base e of e to the -1, -1 to the front. So -1 plus 1 is 0. Okay, so we can sketch those. We'll do these other points first. So 1, 1, E2, and so on. So we've got 1, 1. We can see that that has been shifted up a unit. Here we've got E2, and over here we've got E squared 3. Okay, and down here we've got 1 on E, which is about 0.37-ish, 0. Okay, so you can just sketch this. All right. So just try and use a pencil, actually. All right. The blue curve, y equals log to the base e of x plus 1. Okay. Now for the last page, just looking at comparing log to the base e of x, which we've already drawn many, many times. So just filling in your table of values for that. And so we can see that this curve over here on the right is log to the base e of x. All right, so you've got here the 0.10, you've got the point here e1, and you've got here about there e squared 2, sorry, e squared 2. Okay, so this is y equals log to the base e of x. All right, and look, you could, if you want, here put the point 1 on e negative 1, and so on. All right, and on the other side, notice we've got log to the base e of negative x. So whatever you're getting for 1 on e squared now will be the value you get for negative 1 on e squared, because the negative of negative 1 on e squared gives you this value. So this would give you negative 2. Okay, so this is just a reflection in the y-axis, because what was once positive y values are now the negative y values, and so on. Log to the base e of negative 1 on e will just be the same as 1 on e, which is negative 1. Negative 1 is positive 1, so that gives you 0. Negative e is the same as log to the base e of e, which is 1. And log to the base e of negative, that just gives me e squared, which is 2. Okay, and just plotting those, we've got log to the base e of negative x. I'm just putting some of these values here. You've got negative e squared 2. Here we've got negative e1. Here we've got negative 1, 0, and so on. Negative 1 on e, negative 1. Okay? Now, negative log to the base e of x, that is just the log to the base e of x curve, which is up here, reflected down into the x-axis. So this is just the graph of log to the base e of x, reflected in the x-axis. Okay, so what was once negative values here will be positive, and what's positive here will become negative here. So these values are just switched around. Okay, and you can just plot those on your graph as well. Just checking what you've got there. We can just see that it's the graph of log to the base e of x reflected in the x-axis, down into the x-axis. Just put a few points on it. And here, if you compare these two, this is now, yes, it has been reflected in the x-axis, but it has then also been reflected in the y-axis, because when wherever x was positive, now it's now negative. So now again, just doing a sideways swap of these. So what was negative e squared is like e squared, which gives us this value here of negative 2. Then we'd get negative e squared, negative e, which is positive e. Log to the base e of e is 1, but negative, so it's negative 1. This would be 0. Here we would have 1, and here we would have 2. So this is therefore the graph of log to the base e of x, reflected twice. It's been reflected in the x-axis, that gives us the negative out the front, and the y-axis. So there are two reflections there. So this is log to the base e oh sorry, negative. This is y equals negative log to the base e of negative x. Might want to just plot a few points, negative e squared negative 2. Here we've got negative e negative 1. Here we've got negative 1, 0. And here we've got negative 1 on e and 1. Okay? And that's the end of that booklet.